Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about isometric projections. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now today we will be discussing about the isometric projections of the pentagonal pyramid, and we are going to discuss these isometric projections when this pyramid will be located in the different orientations, right? So let us see how we can go about the construction of the isometric projections of this pentagonal pyramid. So we have been provided with a vertical regular pentagonal pyramid which is resting on its base in the horizontal plane, and the side of the pentagon is given to us as 32 millimeter and the height of the pyramid is 60 millimeter. Now in the case of the isometric projections of pyramid, we have already discussed that this is the base of the pentagonal pyramid, right? So this is the base. So in the base we have observed that this edge will be lying on the isometric axis, whereas the remaining four edges of this pentagonal base of this pentagonal pyramid, they are the non-isometric lines. So we cannot construct the non-isometric line straight away onto the isometric projections. Why? Because the angles, they are not preserved in the isometric projections, and even the shape of this pentagon, it will not be preserved in the isometric projections. So what we have to do to begin with, step number one, we have to go for the geometric construction of the true shape of this base of the pentagon over there, right? So step number one will be, you start with this construction of the pentagon, that is the true dimensional shape will be required. So this we are going to take as 32 millimeter, the base edge which will be 1, 2, and then the external angle from point 2 will be drawn equal to 72 degree, and again the same edge of 32 millimeter will be drawn over there. Similarly, from the point 1, once again external angle of 72 degree will be drawn, and the edge length of 1.5 will be again equal to 32 millimeter. Thereafter, from this extension line, again the external angle of 72 degree will be drawn, and the edge 4.5 will be drawn equal to the edge length of the pentagon base, which is equal to 32 millimeter. And finally, we are going to extend this as a projection line, and again the external angle will be drawn as 72 degree, and the edge length of this edge 3, 4 will be drawn to be 32 millimeter. So once we construct this pentagon, that is 1, 2, 3, 4, 5, and then join it back to 1. Now we have to draw a rectangle ABCD which will be inscribing this particular pentagonal figure over there. So this is the pentagonal shape 1, 2, 3, 4, 5 that we have obtained, having the edge length or the edge of the base equal to 32 millimeter. Then we will be inscribing this into a rectangle. So if we draw this rectangle over there which is going to cover this entire pentagon, we will find that there are two edges. Edge AB, it is equal to X millimeter, we will say. Similarly, the edge BC will be there, which will be equal to Y millimeter, right? So we will say that this longer edge of this rectangular surface over there will be equal to X millimeter, and this shorter edge of this rectangle will be Y millimeter. So we are going to measure the exact dimension over there. So these dimensions, all dimensions will be the true length, and having drawn this rectangular figure which is going to inscribe this particular pentagonal shape over there, next step is that we have to start with the construction of the isometric projections of the pentagonal pyramid. So for that, First step will be construction of the isometric scale, in which true length will be drawn at an angle of 45 degrees. So this is the true length scale, whereas this one is the isometric length scale. So the isometric length scale will be drawn at an angle of 30 degree. And then we are going to mark the true length distances on the true length scale, and then we will be drawing perpendiculars onto the isometric length scale, and this is the isometric length which we have to convert, and these isometric lengths corresponding to the true lengths which are given over here, so these will be drawn onto the isometric projection. So let us start working with the isometric projection of the pentagonal pyramid. So step 1, we have to draw the horizontal ground line or the datum line. Then we will be marking a point over here, and we will be drawing x-axis and the z-axis over here. So this x-axis and the z-axis, they are going to contain these two edges of the base. So the longer edge will be corresponding to x dimension, and the shorter dimension y, it will be located in the other direction. So let us see, here we have drawn the longer edge on the x-axis. So this distance we have marked equal to x millimeter. Now this x millimeter is the isometric length of this distance x over there. So this distance x we are going to measure on the true length scale, and then this will be converted onto the isometric length scale. So this is the isometric length distance of x over there, right? So this we have drawn along the x-axis. So by drawing this distance, that is the larger distance of this rectangle ABCD onto the x-axis, so we have maintained that we are going to draw these edges, either this edge or this edge over there. One edge will be drawn on this line and another edge will be drawn on this isometric line, right? So first of all, we have marked the x millimeter distance starting from this origin point, right? So this is the origin point. So as we move along the x-axis, so we have marked this longer distance of the rectangle ABCD, that is distance x. Then on the other side, we have marked on the z-axis the shorter dimension, which is equal to y. So please check, the shorter dimension has been marked onto the z-axis over there, and the distance which has been marked, it is equal to isometric length corresponding to this true length of y, right? So now it means that along this direction I am going to mark these points over there. So points 3 and 5, they will be lying on these two edges over there, whereas points 1, 2 and 4, so they will be lying on these lines. So let us see, where do we mark the different points. So these are again the isometric edges which are corresponding to this rectangle. So this edge is the shorter edge, and this is parallel to the isometric axis z over here. Similarly, this length is equal to x, and this is parallel to the isometric axis, so we call this line as isometric line. So this is also isometric line, this is also isometric line. Now we have been able to draw this rectangle shape which was obtained as ABCD, right? So onto the isometric projection plane over there, and this is the base. So since the pentagonal pyramid is resting on the ground on its pentagonal face or the base, so this A1, 2, 3, 4, 5 points of the base, they will be drawn along the XZ plane. So this is the X plane, x-axis, and this is the z-axis. So let us start marking the points. So here we have assumed that this edge, that is AB, which is housing the edge 1, 2 over there, so this is located along this particular isometric line. Okay, so A point has been located here, B point has been located here, this is my point C, this is my point D. I could have taken A over here, B over here, C over here, and D over here. So that is another construction which we are going to take up in a short time, right? So for the time being, we have taken point A over here, B over here. So it means this edge 1, 2, it will be lying at this particular position. And another thing we have carried out after constructing this pentagon is we have worked out the axis point, because in order to construct the pyramid we need to work out the axis for this pentagonal shape. So how do we obtain the axis? In order to obtain the axis, what we are going to do, we have worked out, please check, midpoints of all the 5 edges of this pentagonal shape, right? So midpoint of all the 5 edges of this pentagon has been obtained, and then we have drawn perpendicular bisector from every corner. From every corner we have drawn the perpendicular bisector onto the opposite edge. So from this 5, this is the perpendicular bisector. From this 5, this is the perpendicular bisector. From 1, this is the perpendicular bisector. From 2, this is the perpendicular bisector. And from 4, this is the perpendicular bisector. So wherever these 5 perpendicular bisectors they will be meeting, so we are going to get the axis point over here. So this axis point we call as O and O1. So O is the axis point at the apex or the vertex of this pentagonal pyramid. O1, it is the axis point at the base of this pentagonal pyramid. And then we are looking from the top. Now we can join this point O, that is the vertex or the apex point, with all the base point. So these are the slant edges which will be visible to us from the top view. So this is the top view in which all the slant edges O1, O2, O3, O4 and O5, right? So all these slant edges they have been joined. So we are able to see 5 slant faces. You see, this is first slant face, this is my second slant face, this is my third slant face, this is my fourth slant face, and this is the 5th slant face over there. Now next is we have worked out the rectilinear distances for this axis over there. So please check, I have drawn one horizontal locus line, center line, corresponding to this point O. So this distance of this point O from this locus line of AB, from the datum line of AB, happens to be distance F. So I am going to measure this distance of point F from B. So this horizontal line construction corresponding to the axis will be located. Similarly, from the point A, I am going to mark this point as point E. Point E was the bisector of the edge 1, 2, and this was joined by projector from point 4. Okay, so this is my second rectilinear point corresponding to the axis O point over there. So I am going to measure the distance of point E from point A. So once I measure this distance, I will draw one center line. Once I measure the distance of B and F, I will be drawing the second center line. So my axis point will be located within this rectangle as well, right? So once I locate that axis point, I will be drawing the axis, and then all the slant edges I will be able to locate, because I have already told you there is only one edge, 1 to 2, on this pentagonal pyramid base, which is going to lie on the isometric axis. It will be lying over here. Edge 1, 2 of this pyramid base will be lying along this isometric axis or the isometric line, whereas all other, you see, lines, edge 1, edge 2, 3, edge 3, 4, edge 4, 5, edge 5, 1. So they are all the non-isometric lines. So you cannot draw them straight away. So what we have to do, we have to measure the rectilinear distances in order to be able to locate all these line points over there. So similarly, the rectilinear distance of axis point O will also be located. Now you see, I have drawn this rectangle. So having drawn this rectangle, now I am going to do two things. I will be measuring the true length of this distance AE, transfer it over here onto the true length, and work out the isometric length corresponding to this distance of AE. This is again a straight line distance or a rectilinear distance. So from A, I will be marking point E over here. Again a center line will be drawn. Similarly, from point B, I will be marking the distance. I will be measuring the distance of point F, right? The true length will be measured. and then once again this true length will be converted into the isometric length, and this isometric length will be drawn over here. Again the second center line will be drawn. So wherever the first center line through point E and the second center line drawn through point F, wherever they intersect, we will be able to obtain the axis corresponding to this pentagonal pyramid. So please check, this is the isometric distance of AE, whereas this was the isometric distance of AB, that is X. So this is the isometric distance of AD or BC, which is isometric distance corresponding to the distance Y over here. So now I will be measuring the distance of point B with point F over here, and the isometric distance will be projected over here. Now second center line will be drawn. So with this construction, I have been able to work out through rectilinear distances measurements the center point or the axis point of this particular base of the pentagonal pyramid. Now I will be measuring this distance. Please check, A to 1, B to 2. So these two distances, they will be equal, A to 1, B to 2. So once again the true lengths of these distances will be measured, and again they will be converted into the isometric distances. So once I obtain the isometric distances corresponding to A1 or B2, I am going to mark points 1 and 2 over here. Distance of point 1 from A will be marked here. Distance of point 2 from the B point will be marked over here. So let us do it. This is my axis point. Now this is the distance of point 2 from edge B of this rectangle. This is the edge B of the rectangle. So the distance of point 2 will be measured here, converted to isometric length, and it will be transferred over here. So this gives me the location of the point 2 of the base of the pentagonal pyramid. Similarly, distance of point 1, and please make sure this distance and this distance should be equal. So distance of point 2 from B and distance of point 1 from A should be equal. Similarly, distance of point 3 from the end B, again this will be measured, and this will be equal to the distance of point 5 from the end A of this rectangle. So these two distances, they will be equal. So we are going to measure the true length over there in the geometric construction that we have done and convert it into the isometric length distances, and then we will be getting the other 2 points, that is B3. So I'll make this distance, I'll cut an arc over here corresponding to B3, and then this isometric length B3 will be worked out. So this will give me location of point 3. Similarly, A to 5. So same length will be there, A to 5. So point 5 will be located over here. Next, finally, I have to locate this point, which will be my point number 4. So it is basically the midpoint of CD, but still I will be measuring this length, C to 4 or D to 4. So both of these lengths, they will be equal, whether you measure D to 4 or you measure C to 4. If you are measuring D to 4, you start moving from this side. If you are measuring C to 4, and obviously it will be coming along the center point, right? So this is my center point, and once I locate this point, I'll be marking this point as point number 4. So all the 5 points of the base of the pentagonal pyramid, they have been located using rectilinear distances. You cannot draw non-isometric lines straight away. There is only one isometric line. Rest all the 4 lines, they are the non-isometric line. So why do we say they are the non-isometric lines? Because they don't happen to be parallel to either x-axis or the z-axis or the y-axis. So they are not parallel to the isometric axis lines over there. Now this is my axis point. I told you that O1 is the basic axis point which is lying on the base, whereas O point is the apex point corresponding to the axis. So now I know the axis length 60 millimeter. So once again the isometric length 60 will be evaluated, and then we are going to mark a point on the apex or the vertex. This point name will be point O. So this is my point O. So once I have obtained this point O, Now my job is simple. I have to join O1, O2, O3, O4 and O5. Now I will see which of these slant generator, which of these slant edges they are appearing in the front view on the front side of the observer. Please check, observer is going to look at this pyramid from this side. So if I join O1, this edge is visible to the observer. So I have to join it dark. Then if I have to join O5, again this is visible to the observer. If I have to join O4, again it is lying on the front side. It is visible to the observer. But if I have to join O3, again it is visible because it is going to form the outermost boundary. But O2, this is the edge which is lying on the back side, right? So this edge, vertical edge, will not be visible. And then let us join all the points of the base as well. So once again, please check, this edge of the base will be visible to the observer. This edge, it will also be visible. This edge will be visible, but these ones, they will be lying on the back side. So these edges, they will not be visible. So please check. Now I am going to join all the edges of the base. 3, 4, it is edge of the base which the observer can see. So this has been drawn darker over here. Again this edge, this is again facing the observer. So this will be drawn dark. Next one, again this is visible to the observer. Observer is looking at this pentagon base from this side. So this is again visible, drawn dark. But this one, 2, 3, it is lying at the back side, right? So since this edge is lying at the back side, we have drawn it with lighter color, 2H. So this will be drawn with lighter color and the thickness is also less. So these are object lines. This is the construction line. Similarly over here, H1 to 2, this is also lying on the back side. So this will be drawn by using construction line. So please make a note, there is no space for hidden lines in the case of isometric projection. So I cannot draw these lines dotted in the isometric projection. They have to be drawn with thinner construction line or the thinner projection line. So only for the purpose of construction we have to show them. Otherwise, even if we omit them, it is okay. But then we will not be getting the feel of the pentagonal pyramid. Now let us draw the slant edges. So this is the boundary. So this is visible. This is in the front side, H, O4. So this is also visible. So O3 is the boundary. That is why it is visible. O5, it is again lying in the front. So this edge is also, slant edge is visible. O1, this edge lies in the boundary. So again this is visible. But O2, this is lying at the back. So it's not to be drawn dotted. It has to be drawn using only a thin construction line, so that we get the complete feel of this object over there. That is 5 slant edges are there, 4 are visible, 1 is not visible. There are 5 edges of the base, 3 edges of the base they are visible, but 2 edges of the base they are not visible, right? So these 2 base edges, they will be drawn lighter. This slant edge will be drawn lighter over there. So this is the construction of isometric projections of the pentagonal pyramid. Now here you see, we had assumed that this isometric edge which we had drawn 1, 2, it was away from the observer. So we had assumed that this corner point, that is this corner point, so this was facing the observer. Now we are going to make another construction of this isometric projections of the pentagonal pyramid, assuming that this edge 1, 2, it will be facing the observer. And let us see what difference does it make in construction as well as in the projection of the edges which will be visible to the observer and which of the edges will not be visible to the observer. So let us do that. And this is our second construction. In this, once again, along the x-axis, the longer edge has been drawn, this one, and along the z-axis, we are going to draw the shorter edge which will be y. So along x-axis, we have to show x dimension. So, and along the z-axis, we have to show the shorter dimension of the rectangle. It is this one. But now the difference between this construction and the previous construction was that In the previous construction, we had assumed A point, B point over here. That is this edge, this phase. We had assumed that this is away from the observer. But now we are going to assume this edge 1, 2. This is going to be facing the observer. So if 1, 2 has to lie over here, so this corner name will be A, this point will be B, this will be C, and this will be D. So the orientation of the pentagon base we have changed in this particular case. So rest of the construction will remain same. So once again, from point A, I will be measuring the distance of point E. From point A, I will be measuring the distance of point E. Point E center line will be drawn. Similarly, from point B, I will be measuring the distance of point F, and this distance will be marked over here. So the second center line will be drawn over here. So I will be able to locate the center point or the axis point on the base corresponding to this pentagonal base over here. So let us do it. So this is one center line by measuring the distance between A and D. Now I draw the second axis line by measuring the distance between points B and F. So this is the distance between B and F. This is the distance between point A and D. So this is the axis point which has been located. So axis point on the base is O1 and axis point on the vertex or the apex of this pentagonal pyramid is point O. Now having located the axis point, let us locate all the 5 points of the base of the pentagon. So let us do it. So from point A, I have measured the distance of point 1. Similar will be the distance of point 2 from point B. So from A, I locate this point 1 as I move towards end B over here. So this point 1 has been located. Similarly, from B, as I move towards end A, so this same distance will be drawn over here, which is equal to isometric length corresponding to this distance B2. So point 2 has been located. Then I will be measuring the distance of point 3 from point B and point 5 from point A, and both of these distances, they will be equal, right? So I'll be marking these two distances. From B, distance of point 3 has been marked, and from point A, distance of point 5 has been marked. And finally, regarding the base, this is my point number 4, right? So this will be lying at the center, but you can even measure the distance of point 4 from C or distance of point 4 from D. So this point 4 has been located. So all the 5 points of the base of the pentagon, they have been located. Now let us work out the axis. So the axis length is equal to 60 millimeter. So we'll be measuring this axis length. Please check. This is my 60 millimeter height of the axis. Now I get a point of the axis over here, which is point O. And once I obtain the point O, now I have to join all the slant edges. Now whichever slant edges they are facing the observer, they will be drawn dark, and whichever slant edges they are away from the observer, they will be drawn light. So please check, O4 will be light, O5 not dotted, it will be light not dotted. Similarly, corresponding to the base, this edge will be light, this edge will be light, this edge will be light, and these two edges, they will be dark. Let us draw it one by one. This is light. Only two edges of the base will be dark, because these two surfaces corresponding to the slant triangles of the pentagonal pyramid, they are going to cover rest of the slant edges over there. So please check. Going by the construction, you can see this slant surface, this one O23, it is quite big, and O12, these two slant surfaces, they have covered the other 3 other slant surfaces over there. This is the second one and this is the third one, right? So this way, so this slant edge will be light not dotted. This slant edge O4 will be again light not dotted. Similarly, the edge of the base 3, 4, 4, 5 and 5, 1, they will also be light because they are the hidden edges. So even if we do not show these 5 edges over there, 2 slant edges and 3 base edges, our construction will be fine. But once we are joining them with the help of thin lines, so this makes our construction much more easy to understand over there. So we are able to interpret that this is the construction of a pentagonal pyramid. So this is how you can see in the previous case 4 slant edges they were dark. Here the 3 slant edges they have been worked out to be dark. So this way, even if you draw this edge A, B over here, you will find another construction. So that you can try, right? So let us see the comparison. So when we had assumed that this edge 1, 2, it is lying on the back side away from the observer and this corner is facing the observer. So this is the construction that we had obtained. Next, we had assumed that this edge, which is the isometric edge, so this is closer to the observer, whereas this corner now we have assumed this is away from the observer. So this is the difference in the construction. So once again, only one edge will be on the isometric line. All other 4 edges of the base in this construction as well and in this construction as well, they are the non-isometric line. So the rectilinear distances we need to measure and plot all these points over there. So this is all about the isometric projections of a pentagonal pyramid. So we have worked out 2 orientations over there, right? So we will be continuing with the discussion regarding few more cases on the isometric projections of the solids in the coming lectures. So this is all for today. Thank you very much.